appears to be live, but we better check. As I have some suspicion there may have been a fuck up. We'll see. Appears to be live. All right, so we're okay. One can sort of, yes, we can say that. It looks like it's okay. What the hell is everything over here for? What the hell is this? Beats the hell out of me. Anyway, hopefully I didn't screw anything up. Better make sure, maybe. Well, it's too late to make sure, I think. Well, I can try this window. That doesn't tell me anything. Sorry, just a little bit of technical difficulty. All right, so we should be okay now. I guess I'll make this text a little smaller so it fits. I'm too lazy to resize the window. It's negative, right? Maybe that fits better. I suppose I can look to see if it does. Yeah, that fits a little better. Anyway, I gotta scroll up here, maybe. Yeah, that'll work. All right, so first person first kind of thing. So Ket of the Wiser or something, Cato the Wiser, leaves a link to the video, which is always a little bit annoying, but whatever. According to this theory, I don't think I really hate when somebody says that just because you're like, no, according to your interpretation of the theory. No, not the theory, not what I said. This is stuff you put in there, not stuff I put in there. I did post some earlier comments about the light thing, but that really wasn't important. It seems more like ABC than MIT. I think universities rely heavily on this persistent perception that having some foreign accent makes you some misunderstandable genius or great talent. Meanwhile, the opposite true for a Southern U.S. accent. Well, I mean, they are different, so if you don't understand the difference, I mean, people can be foreign and be highly educated, where we know most of the people in the South are frickin' idiots. They aren't well educated. They aren't in any way sophisticated, and so generally speaking, it's true. I mean, as a profile, in reality, Europeans who have learned more than one language are obviously going to have more likely to be educated than Southern bumpkins who haven't even figured out how to speak one language right. Just a fact. Let's see. Oh yeah, here's a comment I wanted to deal with. I haven't gotten to yet. Can you show us that the glass has an opposite charge on the other side? Question mark. Well, I'm not the one contending the glass has an opposite charge on the other side. I was the one stating that I don't think it does. So Professor Lewin's moving the charge through the insulator thing sort of is bogus, because the charge doesn't go positive on one side, negative on the other side. You have to put it there. So yes, I have been attempting to do some glass experiments, but I've just been having a little trouble because of the humidity here, or whatever. I just haven't gotten any substantial charge to stick to anything here. So, I have to do some better insulating, I guess. All right, so let's see. That is pretty remarkable to me. I've seen it. So I was talking about the light thing. I don't think that's too impressive. Okay, joke. Yeah, okay, jokes are fun. Anyway, all right, so good. We're back to this comment. All right, according to this theory, if two black objects were held close, right, two electrons, like in that drawing, yes, the black force would deplete after a period. Why? Why would it do that? I said in the video, it could be billions of years, that the energy is trapped inside of an atom. Why would it deplete? Where's there evidence that photons run out of steam? They travel billions of light years. They don't run out of gas. And this is the same force that a photon's made out of. I mean, there's just no evidence that there's any depletion. I don't know where you got this idea that it has to deplete. What would it deplete into? It's fundamental force energy. It can only deplete into a different version of the same force. I mean, you can't deplete it into something else. You have to deplete the photons into photons, essentially. You have to deplete the little electron energy. It can only be depleted into another form of electron energy. Electron pressure. Doesn't convert into anything else. After a period, and the opposite would happen. There's no electrons that don't do the opposite. So the only theoretical way that you could possibly have electrons that got close together is if they're bound to a proton. So there's a proton in between the two electrons. So that way they can get pretty close because all the black energy, as stated, leaks out through the proton, and all the red energy leaks out through the electron. So there's nothing to push anything. So everything can get pretty close. And then you could theorize that if you jerked a proton out quickly, the two electrons would be left with little energy between them. So that might be possible. So they'd always be stuck with some energy, presumably, just because some energy always comes in through the proton from the field in through this way. Comes into the proton perpendicular to the alignment. I don't know why it's so hard to keep these in alignment. Perpendicular to the alignment goes out this way, or it goes out this way, and it bounces back in, and but so there's always a little bit of pressure. So the closest you get to electrons, that is, if you can knock a proton out just perfectly, you could end up with a pair of electrons that were absent any pressure in between them, a substantial amount, only a little bit trapped. So what? Not terribly interesting. Not terribly useful for anything. Anyway, the opposite would happen. So there's no opposite would happen. This would be the unusual circumstance, and it wouldn't start off with two electrons repelling each other. So it would have to have the proton in between them. Completely different circumstance than what I was talking about, which is the electrons, when they're arranged in an atom, this proton is just going to show up and change everything. So it's not really applicable to the fundamental theory. 9,999,999% of 1,999% of the time, two electrons are in pressure. The pressure they have is stable. All right, they would be pushed together, right? So they can only be pushed together if something exists to get rid of the force between them. So again, there's only they'll do what the force tells them, in the sense that if there's an absence of force, then the outside force is stronger. If there's a presence of force, then the interior force is stronger. And it's just kind of obvious that if you put two ping pong ball battles and the ball stays between the paddles and bounces back and forth, that there's a point where I can almost get to an infinite amount of pressure. Jeez. Let's see. They would push together, right? Well, I'm not going to agree with anything. I'm not agreeing with your premise, so I'm not saying right to any of that. Might be a moot point. Well, maybe, yes, because it would be very hard to show experimentally. Everything's hard to show experimentally on this level. That's really not the point. The experiments do show behaviors, and then you have to have some mechanism that conforms to those behaviors. Frankly, there isn't all that much behavior that requires me to worry about this, but whatever. But again, I believe electrons do act as pairs under some circumstances. I don't know how they would actually act as a pair, and whether that would be of any use at all, frankly. Can't think of one off the top of my head. So it may fit. Says you. Are you familiar with Cooper pairs? Yeah, well, this like again, you know, this theoretical subatomic quantum crap. Their whole theory is wrong. Fundamentally, I'm arguing. All right, the forces here are not, or you know, things aren't orbiting, just being held by gravity. There's not that kind of force tension. Things can certainly move, but the real game is that everything's in kind of magnetic positions, and it's magnetic tension, in the sense that that's the fundamental force, in a sense, the charge force. And again, if you understand how it works, you understand that, you know, you don't need external pressure to make that happen. Okay, the fact that there's low pressure between this electron and this proton doesn't mean there's more pressure on the outside. The fact that these are closer together, these two electrons. The external pressure didn't make that happen. The circumstance that this thing is leaking the pressure is what makes it happen. So their whole understanding of the strong force, which is exactly the opposite of this, you know, in the sense that the protons are getting close together, they're not understanding that the neutron is providing the electron that allows the two protons to get together. So I'm just saying that the whole model is so flawed that I have no interest in conforming to their assumptions, because that would just be breaking the good theory. You're just polluting it with bad assumptions. All right, nobody thinks you're going to win the Nobel Prize except me. Well, that's a nice thing to say. There have been a couple other people who have acknowledged, but I don't know how sincere that is, but Ocolito, I'll take it at face value and enjoy it. Thank you. All right, if you say at 820 that the negative ion is moving towards the zinc side, you're going to get into all this complex chemistry. I wasn't making a complex chemistry argument. I was just making the argument that there's no current running inside the fluid. There's no forces. It's the fluids being stirred up and the stuff mixes. But it's not like the ions are being hard attracted somewhere. Obviously, when they get close to the electrodes, they probably are. But I don't think there's any obvious, like if you pour food coloring in there and watched everything, I don't think you'd see some obvious, you know, streams going back and forth. It's just the fluids mixing. So the ions are, the acid knocks something off, and either the copper can go back on or a piece of zinc can go back on. But the fact is, the copper, the zinc can go on the copper, but the copper doesn't stick to the zinc, you know, and just a rule. So there's an asymmetry. Part of the reason why one pole goes positive, one pole goes negative. And the acid is just there to knock molecules off. So it's just knocking atoms off of both. And then those atoms are disproportionately collecting on one electrode because both zinc and copper are sticking to one electrode, where the other one, just the zinc, goes back on. That's how I would look at it. That's how I would simplify it. And so then when you reverse it, you're just saying, strip off all the crap I put back on this electrode and let's start over. So anyway, let's see what else you said here. Unclear why. This can only work when S is positive. So I don't know what that means. Lewin draws a green arrow in the direction of the zinc plate rod, and he says positive flows in the left direction. It flows in every direction. I'm just saying the ions are just freely flowing around, and they're just exchanging pressure. They're just saying I'm high pressure, or the other ion saying I'm low pressure, and they're banging into each other, exchanging pressure. And so if it goes to the copper and it's got a high pressure, it sticks because it's bonding to a low pressure. So it's like a 3 and a 5 hit, and they become neutral 4s and they bond. You know, but it's not a very strong bond because the acid is still going to hit them and knock them loose again. All right. C plate, and he says positive flows in the left direction. Does he lie? No, he just makes up stuff. I mean, obviously they all make up a theory about how stuff works, and that's sort of what they've done. They have a loose idea. This is how I imagine it. It doesn't mean it's doing something. So, I'd like to talk some more about this idea, these stupid idiots. Sorry. How everybody thinks there's this stuff flowing around magnets. They put arrows on it, make it, there's all this stuff. There's no evidence that anything is flowing around a magnet. Now, there's a certain sense to recognizing that the two poles are different, but there's no sense in saying those field lines are actual roads that stuff travels down, because those field lines are just a graphical representation of the charge strength. And as I've already explained, the reason why things line up on those lines is because they're opposite magnets to the main magnet. They're repulsive magnets. They can't get close to each other. They're all repelling each other. They're all repelling each other. They're magnets all in the same direction, which means they have to repel each other. That's why they always look like lines, but they're not lines. They're not pathways. Anyway, his quantum explanation can only be that the oxygen ion is negative here. But where does the CuOx remain? I don't know. Probably the solution, but not on the Cu plate unless it turns back green. Haha. Well, again, the acid doesn't care. It's working on either plate. And then the asymmetry is just created by the fact that the copper doesn't have any interest in becoming zinc. But the zinc has an interest in becoming copper. The negative oxygen ion is the main character here. Fine. I think zinc is only so much more negative than copper that it can't ask ourselves why we use these two metals when we could use copper elements with a much greater potential difference. Cheaper elements. Obviously, it has to be because you have to have elements that have this resistance, this unwillingness to combine in certain directions. Copper will let zinc stick to it. Zinc won't let copper stick to it. Something like that. I imagine that's the difference. You have to have two elements, which have these characteristics. However to say that. Yeah, it's probably a good enough way to say it, I guess. All right, so that wasn't difficult to take care of. Not much commenting going on, which is, whatever. So I will think, nothing personal, Cato. I'm going to delete your comment just because I really hate according to this theory. It's not according to this theory. It's according to your interpretation of the theory. And again, there's absolutely, I don't even know where you get the idea that the black force would deplete after a period. Why would it do that? I mean, why would photons deplete? Show me a photon depleted. So they don't deplete. Anyway, so I'm going to delete that comment just because, say as I interpret what you said. That's a reasonable premise because that's what you did. You interpreted what I said, in my opinion, erroneously, because I don't know where, I didn't give any indication that the force depletes or weakens or gets tired or any of that crap. There is a question about atoms moving and how the force can move with them, because that doesn't make much sense, but clearly the force is everywhere. So for every bit of force you move out of, you move into another bit of force. And so there's, there's lots of complex arguments about drag and all that stuff. But for understanding the basic structure of the theory, the two forces that make it possible for you to have this creation of high pressure and low pressure, I just, I don't know how you can screw it up. I mean, it's just kind of simple. Force is trapped. I used the word trapped. I wrote the word trapped. It's a key function of the universe, is trapping force. That's why atoms can go nuclear. It's because they have energy trapped in them. Trapped, not depleted, not worn out. So, I mean, obviously the radioactive isotopes can leak energy, but obviously it also takes a very long time for some to leak a significant amount of energy. But geez, and it just shows how much energy is in those atoms that they can leak for 1,000,000 years. They still got plenty of energy. All right. So I guess I could talk about the de Hilster particle theory. I probably should just do a video about it and outline so many flaws in what he says. So he uses this deeper new guy or whatever, this stupid swirling stuff in water. And there's just so many bad analogies here. Obviously, if you even for the magnet people who think these swirly bits have something to do with something, they have to be connected to something, right? I mean, if I push a bunch of sand around me, and the sand can't make me move. So if something blocks the sand that I throw a bucket of sand up in the air, and something blocks it or they don't block it, I'm not going to know the difference. The sand particles aren't molecularly tied to each other, and I'm not going to feel it on my hand. I'm not going to feel it anywhere. The sand's just going to get blocked. That's it. I'm not going to care. So even if I could create a big hurricane around me, that hurricane wouldn't affect me any. And so when somebody else had another hurricane and those two hurricanes were going to hit each other, he's not going to feel it. I'm not going to feel it. I'm not going to care. Yeah, a bunch of little sand things are going to hit each other. So what? Why should I care, and why would he care? The only way we could care is if we did have an ether full of medium tying all the little bits together. So the only way that swirly stuff in David Hilster's theory could mean anything is that you'd have to argue that they were all bound together somehow by some other magical force, G3 particles. I mean, it goes insanely silly, because you still have to create tension out of somewhere. There has to be tension. And so you have two things you need. You need momentum and tension. And you can't make something have movement. Like I said, the only thing that can have the movement is the photons. That's the only stuff that looks like it has perpetual energy. Everything else looks like it has to be hit. It has to be pushed. It has to acquire speed from something. Has to absorb it is the truth. So yeah, it fails for that reason. And it does seem like he doesn't really look into this stuff very deeply, because they have this the stupid swirling stuff that they actually have great videos of vortexes, and that's all that really is vortexes. And they can create them in swimming pools, and you can crash the vortexes into each other and watch them annihilate in different ways. But there's just no evidence of any dramatic attraction or repulsion. It's like an insanely weak force. And magnets are an insanely powerful force, right? I mean, charge is, it's powerful attraction and repulsion, not weak. And so it's just, you'd say, and then another obvious argument is there would have to be, for this to be some sort of force that guides things, the things being guided are only absorbing a tiny percentage of the field energy. It's like, okay, say I have a boat and it's a little bit stuck in the mud, and then I have a stream running. Well, you know, you could say, yeah, the boat's going to tend to line up, so it's going to move because of the stream water. And so it's going to do an obvious lining up thing. But the lining up energy is going to be a tiny percentage of the energy you had to use to line the boat up, right? It would have been a lot easier just to walk out in the mud and push the boat, right? Tiny bit. But the amount of water you'll need to use to make the boat do the same little movement is going to be gigantic. So then you have to explain how magnets are generating all this energy. You know, an insane amount of energy has to be in the field they're creating, because the things moving in the field are only absorbing a tiny percentage of the field's energy. So then you're stuck with this idea, well, how do I explain where all that, you know, 1 billion times more watts of energy are being created to create the field than the things being affected by it? You know, it's almost like Einstein's convergence. You know, it's affecting tiny little bits, but it's pulling on all the space. You know, how's it? Yeah, it just doesn't make any sense. So anyway, it's just a really bad approach to explaining, especially from a particle model point, because you're basically, you know, he's trying to be an anti-ether theory, but the only way the field swirling stuff could actually have an effect is you have to make it not grains of sand that are all acting independently. You have to make it into molecules of water that are all tied together and creating friction and tension. So unless you have molecules of water, the fields colliding or mixing can't have an effect. And the obvious thing that was just kind of grotesquely obvious is that him and the rational science guy, you know, the Bill Gates guy, are both using this effect as an explanation for magnetism. And they have it both. They have their two theories are backwards. The rational science guy says when they're going the same way, that's repulsion, and when they're going opposite ways, that's attraction. And the Hilster guy said exactly the opposite the Friday night. It was like they're going the same way, they're move towards each other, and when they're going the opposite way, they move away from each other. So it's like, make up your minds. And it still doesn't make any sense exactly how this creates attraction without a medium. So it just, you know, there's no point in saying you're calling yourselves particle guru when you're really dependent on some binding force for which you have no explanation, which just can't make any sense. Really can't. You know, you have all this stuff swirling this way and this way on around the two sides of the magnet, and then you'd have to say, oh yes, but there's another particle field of intense swirls going this way, you know, that's pushing them in this side and pushing them in this side somehow to make them somehow relevant to the thing in the middle, somehow relevant to the piece of matter. I mean, once a piece of matter excretes a force, once the energy bounces off me and leaves, it just couldn't do anything. I mean, I just couldn't care less what happens to it, right? It could do anything, and it just doesn't matter to me. I'm not going to feel it. It's only the stuff on its way towards me, you know, or stuff that's being bent towards me that can mean something to me. The stuff leaving can't possibly affect me. So it's just really bad theory. Let's see what else he says. Let's just forget about it. Oh yeah, the photons being made out of a whole sea of particles. You know, big pile of them. One little photon is big million little things, and then a million little things, and a million little things. You know, this can't work because then photons aren't going to have the same mass and momentum. I don't even know how they could have the same speed. And, you know, just this whole idea of creating a whole, some other this infinite physics where you just keep saying it's a fractal or something. There's just no evidence of this fractalness. There's no correlations. And there's clear correlations between our small universe and the big universe, and that the things that are big things in the small universe are small things in the big universe, which means there can't really be a fractal anymore, because there's too many things that are blending into both universes, the very small and the very big. You could argue, like a grain of sand. And there's just nothing like a photon flying around in the big universe. There's no correlation. There's no evidence of anything that has perpetual motion, that isn't made of exactly the same thing that has perpetual motion in our small universe, which is photons. So, there's just obvious gaps in the notion that you can sit there and say it's important here's a who thing or something, like the universe is just layers of the same mechanics, because there's no correlation. And what we also see in the big universe is a simplicity, where we know how those round things got created. Gravity made them, our gravity, and they're clearly functioning within the limits of the same gravity that functions on the lower level, and that force is a consistent force. So you have the same little force running both universes, and no evidence of some underlying force running the other one. So it just doesn't work. Having something, this idea of something going c squared, the speed of light squared, just even contemplating something that on its face ludicrous, because it's basically saying instantaneous speed. And so the effects would have to be pretty much obvious. The effects of a force moving c squared would be that it would be causing instantaneous effects across the universe. If it's affecting things, if it's controlling what they do, then we should see all these evidence of this control. And there's no seen evidence of any of it. They just don't think through this stuff very well. I mean, they really haven't done enough. I'm not blaming him. It just takes time. But it's like he has a completely wrong perception of Lesage gravity. Lesage, call Lesage, but it doesn't matter. In the sense he thought it was some kind of ether theory. It was nothing. There's nothing like an ether theory. Ultra mundane particles. It's a particle theory. And so you should answer the same questions Lesage had to answer, and how your theory deals with those questions. And it's like he hasn't paid any attention to that. Certainly hasn't paid any attention to the drag issue, lots of these others. And, they're important issues, and he just ignored them. So, like he does with his little Earth thing, he just keeps saying, "Look how it looks. It looks like it looks right." But I don't think he would really. I don't think he has any interest in answering the critiques that would point out, well, how do you defend that? How does the Earth make oil and water? What's the chemical process? And what else you could argue about? Where's this matter? How's the Earth manufacturing matter? I mean, it's all, come on. And as I pointed out, if the Earth was smaller, then why don't the dinosaurs look like kangaroos? Why do they look like heavy things with big giant bones? I mean, if they were in a lighter gravity, don't you think they would have been really quick and agile instead of heavy and slow? It's relatively slow. Yeah, I think they would have. I think there would have been lots of bouncing things. Lots of things that just crickets. The crickets everywhere. Low gravity, being a cricket's a great idea. You don't have to worry about hitting things hard, crashing. So yeah, it really works. All right. No, I think I covered what I wanted to cover. I don't know if I have to, no comments, then there'll be no comments. Seems like it should have more viewers during the day, but apparently not. 8 viewers, pretty poor. But it's the way it's going to be, I guess, until I generate more interest in these conversations and such. I really am tired. I don't know why I'm so tired, but I'm tired. Shoot, I just tuned in. Well, too bad. Yeah, I guess you'll have to just watch from the beginning or ask a question relevant to physics or what else? Or something else. Hope. Or what else? Yeah, I could play something, but I really just don't feel like it. I mean, everything's. I mean, I saw another Thunderfoot video, and he was talking about the bottled water thing. And he just drags these videos out, but there was just like glaring. You know, sometimes he does stuff, and it's just you're saying that's not very good research. So he was comparing humidifiers to these machines that pull water out of the dehumidifiers, with these machines that pull water out of the atmosphere for bottled water. And yes, they're just glorified dehumidifiers. And so, but he was using the statistics of a dehumidifier, and he was taking it off the ad sheet. And it's just so stupid to do that, because it tells you how many watts it's using while it's running, and it tells you something else. But when it says capacity, that just means how much it holds. It doesn't mean it's going to collect that much water. So when it says 38 liters or something, it doesn't mean it collects 38 liters of water in an hour or something, or in a day, or 12 hours or something. It has nothing to do with it. So he was using the amount of the size of the bucket on the stupid dehumidifier as a survey of how much water on average is collected, say, out of average humidity by the device, and that's not what it is. That would be nice if dehumidifiers came that way, you know, where they told you how much energy they put in with an average amount, you know, 60% humidity, and how much water they got out. It'd be really nice if they did those rational comparisons, instead of just selling it by saying, look, we have a big giant bucket on ours. We collect lots of water. So yeah, so what? You collect lots, but not much drips into the bucket. Yeah. So yeah, it wasn't very well done in that sense. So annoying. But he kept saying too, the other thing I thought was annoying. See, it is kind of funny. Like you have these extremes, right? You have the 180 zigs, and then the people correcting them zag way too far the other way. So you have these idiots zigging with free energy, but then you have the people, you know, arguing against those tinfoil hatters by zagging, saying there's no such thing as free energy, when we really shouldn't say that. There's lots of free energy. I mean, you know, the apple could hit you on the head. That was free. Okay, it was free energy. You didn't have to do a damn thing but walk under the tree, right? I mean, walnuts, black walnuts are a real threat. You know, kind of heavy, and you know, it can kill you. It's free energy. It's enough to kill a human being, and it's free. So there's lots of free energy in the sense that we don't have to. There is no chemical reaction. There is no blah 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 that we have to go through. We don't have to put any energy in, so to speak, to get the energy out. We just have to make a device that collects it. So in a sense, solar energy is a little bit free-ish, you know, except the device to collect it could be kind of expensive and be made out of compounds that aren't renewable and all kinds of stuff like that. But clearly, hydroelectric is free. I mean, you know, the heat of the earth puts the water up there, and then we can collect all the energy of it going back down. And all we have to do is tie a magnet on a stick, theoretically, and let the water spin it. I mean, you know, the water wheel. I mean, it's pretty free, right? I mean, that's not very expensive energy, right? Putting a wheel on a stick, that's not very expensive energy. So in a sense, it's free. But the problem is not much sometimes. Or the free energy, like nuclear, right? I mean, it's right there. I mean, it's a bunch of free energy inside these atoms, you know, except the fact is it's messy getting them free, you know, get setting them loose. Just like it's messy to let the oil loose and the coal and burning stuff. It's dirty. And so the problem is finding a clean way to pull the energy out without it getting radioactive and all that shit and all the, you know, but it's frickin' free energy right there, free. Free to steal. So in a sense, they go way too far. And yeah, the argument about the thermodynamics of pulling water back out of the atmosphere, obviously it went into the atmosphere because that was the energy sink. That was where the lower amount of energy was to be vaporized. And so you have to reverse that without somebody doing it for you for free. I mean, the only way to do it for free would be if the atmosphere went stone cold at night and you were able to collect the condensation or something. Well, then that's free water, right? So you could just put up a piece of steel and hope the nighttime temperature is cold enough and you can collect some little drips of water. Well, that's free water, but obviously it's not going to be enough. And if you want to force it back out in some non-free way, then you have to freeze the atmosphere, and that's essentially what a dehumidifier is doing. Is it's just basically having to cool the hot to get the water to fall back out. You know, so there's a free way to get it, and there's an expensive way to get it. A dehumidifier is obviously forcing it, so that's the expensive way. Trying to find some way to have hot air mixed with cold air, like a thunderstorm. You know, that's the free way to collect a bunch of water. All right. You know, just are you that guy on TV? Gee, that doesn't really. No, I don't think I am. A couple years ago, no, I don't think so. That created a continuous battery. So there's a guy on TV who did that, huh? Yeah, I don't think so. I don't remember that guy. I don't have a TV, so I don't know. I know TV's gotten really dumb, but I didn't think it was dumb enough to think that it created a continuous battery. I mean, I suppose I could make a continuous battery, you know. I could put a magnet on my hand and, you know, wank all day. Anyway, I drank my urine by mistake. Well, that's interesting. It didn't it was clear because it did not eat oatmeal cluggers. I don't know what all this. It's too hard to read even. So, I hope you die soon in a miserable and horrible way. Just to teach all the little rotten trollers that you will be doomed by just some sort of force in the universe that says kill the motherfucking cunts really badly because they deserve it. I really do hope you get exactly what you deserve, what you've earned with your little shitty existence, which is to be fucking half roadkill, squirming on the side of the road. And then I see you and I stop my car and then I just kick you to the fucking curb. Yes, you scum. What useless sacks of shit. Some special on Net Geo with some dude that created a continuous charging battery from scratch material. Again, well, whatever this is. So do you believe in continuous batteries? What is the point of bringing this crap up? I saw a dog poo on the edge of a curb. I mean, what else are you going to talk about? What do you have anything, I mean, meaningful, relevant? You saw somebody dressed as a witch? It's like almost Halloween. What other remarkable news story are you going to inform me about? Jesus Christ. Well, again, so you can say entropy makes infinite batteries impossible, but it depends on what you mean by infinite, right? Because let's just say I make a device that can deconstruct atoms one at a time. So atom goes into a little box I make, and the atom is basically imploded, and I get all the energy out of the atom, right? And 12 volts. Theoretically, right? Realistically, with the number of atoms in the universe, that's an infinite battery, right? I mean, it's going to take an awful long time for me to run out of fucking atoms, right? Let's say I go through one atom and see, to create like enough voltage to run a city, what do I need? 20 atoms a minute, maybe. So I using 20 atoms a minute. I mean, do the calculation. I mean, that's going to be one hell of a forever battery. Well, I'm just saying, if we used a practical limitation to the word infinite, and we're just saying very long time battery, very, 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 very long time battery, well, that's doable. Yeah, the battery was pretty cool. He used it to recharge his laptop in 1 hour. You're just talking crap, okay? It's just nonsense. I'm sure he didn't create anything useful, or we'd all be using it, wouldn't we? Right? Right? And you can't continuously charge a battery without a source of charge. What was his energy source? Well, you're 13 and you're telling adults, 59-year-old men, to take a chill pill. Go fuck yourself, you little twerp. God, they ought to age restrict this fucking place. Shitty little turd. Ugh. It took energy to build the atom, though. Who's arguing that it didn't? I didn't know the subject was a battery that doesn't require energy. Oh, okay, never mind. Yeah, the battery that doesn't require any source of energy. Yes, that doesn't last very long. You don't get much out of those. The no energy battery, yeah, no. Zip. It's like an infinitely short period of time you're given electricity. But in a sense, I would argue it took energy to build the atom, though. But the truth of it is that energy is the permanent energy in a sense. That's that gravity stuff, the force stuff. And it's perpetual. Always going somewhere. So you letting it go back to being in the field didn't deplete it in any way. Still the same energy. So yeah, I just don't know if these absolute terms work in a universe that actually has something that has perpetual energy in it. And photons have it. Photons have perpetual energy. And I would argue that if I throw this into outer space, free of gravitational influences, it will have perpetual energy. Because it'll create a little photon engine. It'll just keep pushing it through space. So exactly the point. Energy is never consumed, it's just converted. So isn't that kind of anti-rhetoric to the idea that there's some way of consuming energy? Or some obligation to make it? It's already out there. You just don't have the right tools to collect it. But you need some mechanism to make it go from unusable to usable again. So again, you're just not getting it. They're just devices that take advantage of the conversion. So all you need is a different converter. So you convert it into black, and then you create another machine that gains the energy when you convert from black to white. So you have one machine that collects the energy from white to black, and then you have another machine that collects the energy from black to white. It's all downhill. The photon is always going downhill. It's just the only catch is photons are going this way and they're going this way in equal amounts. And you just have to find the places where it isn't equal. There's more going this way than going this way. Or you have to make a machine that is able to make these go this way and those go this way, and then make them go this way and this way. And now you have them going opposite ways. Now you can get their energy. So if you can turn them, then they're going out instead of in, and now you can grab their energy because they'll expand your balloon, so to speak. So instead of canceling each other, you have to bend them. So, you turn them. So now they're not canceling. They're pushing against. I'm just saying it's a gimmick. And all you need is a different gimmick, and a different Rube Goldberg machine at each stage to take advantage of the fact that the stuff is always going to move from high pressure to low pressure. It's always going to move from the direction the photon's here, and it's going that way. So, yes, if I can tie a string on it, I can collect the energy. And when it's going that way, if I can tie a string on it, I can collect the energy. Just depends on, it's just taking advantage of where there's an imbalance. And if there isn't one, creating it. All right. Unusable, usable depends on what tools you have. Well, didn't I just already say that? Didn't I say that there's like an infinite amount of energy technically in the universe, in the atoms? If you take all the atoms in the universe, I mean, that's just so much energy that you could just run the little machine, forever, theoretically, because you're just never going to run out of atoms. If you use one a minute, okay, you've got forever to use. You'll be forever. And it might be that the universe might be recompressing at the same rate that you're uncompressing. So it's just about having it's not just having the right tools. Like I said, you have to understand the place. There's always energy. It's just that stupid, you have to find places where the energy is imbalanced, because it's the imbalance that you take advantage of. You take advantage of the fact that it's 7 going this way and only 5 going this way, and you can collect the 2. You can't collect the 5-5. That don't work. No, that's yin yang. You got to find a place where the yin is yin ya, no yang, and then you can steal the yang. Gravity is free energy. No, it isn't. Ask the hydroelectric suppliers. Again, the gravity is important, but in a sense, it's obviously part of the equation. But what put the water up in the sky wasn't gravity. So let's understand, the water went up through not gravity but thermodynamics. So it's kind of silly to say it's free gravity when you're really taking advantage of the heat energy that put the water up there, that put it on top of the hill, that created the imbalance. hydroelectric energy is photons. No, I don't think so. It's mass. It's matter. Obviously, the photons pushed the water up. So, yeah. But, that doesn't make much sense to me. From the sun. So, it's nuclear fusion. See, you're thinking it's the heat of the Earth is all caused by solar radiation. And that's probably right. I mean, clearly the gravity thing is ripping the interior of the Earth up. Yeah, no, some of that heat does rise to the surface. I mean, not too many of the planets are really stone cold. They're cold, but they're not really cold. They're 58 Kelvin or some other kind of number, but they're not nearly absolute zero. So they're clearly have internal heat. So some percentage of the heat is from the heat provided from gravity by ripping and torquing and pressurizing. But yes, most of the surface heat is from the sun. And yes, so technically that part's right. But I don't know how it's fusion. It's a byproduct of what the sun's doing. Clearly, yes. So it's an imbalance created by the sun. So the sun's emitting more photons than it's absorbing. So that's the imbalance. So yeah, that's a reasonable. Yeah, you could say that. Yeah. Fusion is what put the water molecules up to allow them to freely fall with gravity. So it put them on the top of the hill for us to just, have them land on our heads. It sure does it in a complex way. Just thinking of the cycle, energy comes down and then the energy reflects off, and it's just kind of, it's all trying to figure out what exactly, the mechanism, but it's really just buoyancy, right? I mean, the water molecules detach from each other and become buoyant when they're not stuck to each other. So when they become smaller molecules, they're more buoyant, so they float up. Well, and then there's convection. I guess most of them are pushed up by convection. But the convection has to be caused by what goes down. Something else must go up. So when the rain comes down, it pushes more water molecules up, ironically. Something like that. It is, these subjects are so, everything has, if getting into the subtleties, it's all, it is Rube Goldberg. I mean, there's just so many little things to trace, all the little footprints, lots of footprints. Change of state. Well, that's too ambiguous. So I think all the other stuff we've talked about has already covered the word change of state. But again, it doesn't release energy. It just makes energy visible. Again, look, the energy is in the movement of the photons. All you're doing is collecting the imbalance. So there's lots of energy that just isn't in the form of an obvious imbalance. And so you only see energy when there's an imbalance in the energy, but the energy is always there. Well, I suppose I'm arguing that to some extent it is, except it's made out of just 4 or 5 little parts. You know, it's a checkerboard Rube Goldberg. It's a dominoes Rube Goldberg. So you really can, if you can get inside the box and with a magnifying glass, you'll see that all of the all of the shoe dominoes, the bowling ball dominoes, it's all made out of the same crap, just shaped into little stupid different packages, but the fundamental mechanism is made out of the same little building blocks. But what the building, you know, what the things that the building blocks make, the shapes the checkers make can be anything. You know, Richard Nixon's head, they can make anything. And sometimes they make things that end up being imbalance creators, you know, yin-yangers, where the yin ends up pretty far away from the yang. It is like little bombs in a way when you think about it, right? I mean, the universe, the pressure, the gravity condenses, pressurizes, and then all those little pressure bombs get scattered across the universe as little atoms of bombs, little bombs of pressure. So it made a bunch of little bombs, and then it's taken that yin pressure, it releases it, spreads it all over the fucking place, and then those little pressure bombs can blow up anywhere. Yang. You know, kind of funny. Off topic. Well, I don't know if I like that. But what do you think of the computational theory of mind? I don't know what it is, but I'm sure it's crap. We're robots, okay? So we're just the byproduct of reflexes. You know, A plus B equals C, however you want to look at it. If, then, you know, they're just reflexes. Just reflexes, 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 reflexes. Knee jerk, tied to knee jerk, tied to knee jerk, tied to knee jerk. Nothing magical anywhere. Just triggers. That's partly the idea, so it's not really against what you just described. Well, I just don't see as soon as somebody says computational theory of mind, you're not really getting to the thing, which is sensation is one hell of a fucking illusion. So, you know, it's one thing to say it's all an illusion, which it is. But just as Einstein stated about the photon, you know, time is one hell of an illusion. It's clearly a function. I mean, you can't place it anywhere. You can't make any sense out of it in some senses. It's here. There's just no doubt about it. I'm just saying consciousness in the sense of sensation as a phenomenon is always going to be a little disconnected from stating something as binary. It has too much analog to it. It's just such an analog thing. Perception of an actual feeling. Just that felt bad. How did it do that? Computationally. You can't computate a feeling. So that's where it gets a little bit where I start saying these are just nihilists, trying to justify Nietzsche or something. That's just horseshit. You have to go deeper. Yes, it is an illusion. But the fact of the matter is, the illusion created actual value. So there's no value in the material universe. There's only value in that computation. When you do that certain computation that creates a bad feeling, that computation in and of itself, without any help, that number, let's call that computation a number, 50, 60, or 21D2, just make up some kind of abstract number. Whenever that number is made, it's intrinsically bad. That's a bad computation number. That number is intrinsically bad. It's just 666. It's bad, 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 bad. Intrinsically. Whenever it's computed in a brain anywhere, it's always a bad number. That's the weird part. Right. Even if you're scared of a delusion, the delusion is still causing an experience of fear that is happening. I wouldn't compare the two, because we're really not talking about what's causing a sensation. I don't care whether it's real or not real, in the sense that you can think a Maserati is valuable and you can think a kid isn't valuable. So you can have a wrong opinion. It's just stupid, retarded. You can think the car feels and you can think the kid doesn't. You can think really dumb things. That's irrelevant. The point is the only thing that really has value are those feeling things. The feelings are it. That's it in the universe. There's nothing else that can have value except when a consciousness is experiencing a feeling, either relief or torment, good, bad. So that's all there is. There's just bad feelings are the absence of bad feelings. And there's nothing else that has real value. The rest of it's just emergent or connected or associated. But it's indirect. It doesn't have any, you have to make something. This pen cannot mean anything unless it's going to hurt somebody or help somebody feel better or feel worse. Otherwise, it can't mean anything. So any value it has only has value in the sense, I am going to write some brilliant words that will improve the human condition. Then the pen is valuable. But it's only valuable indirectly. The real value was in improving the human condition. That is, making people feel better. So I just wouldn't go with even if you're scared of a delusion. So it really doesn't matter what the source is. The only important word was scare and fear. The only important words are the sensations themselves. Clearly, though, I'm not saying that it doesn't matter if people are deluded. Of course not. It makes them more destructive. It makes them dysfunctional as robots. But I'm just saying from the value point of view, the only thing that really has value is how they feel, not why they feel. In the value sense, the tree that falls in the forest doesn't make noise if no one hears it. Oh, damn. I really hate that. Yes, if no one feels, then there's no tree falling. But again, I just don't like this analogy with the sound and the forest analogy, just because that's such a stupid analogy, right? Because the sound, the tree, whether the tree falls, it makes sound. Whether there's a person around to hear it doesn't change the fact that the tree fell. So I hate that, whatever that is, colloquialism. I hate that phrase just because it's wrong. Okay, it's just stupid. Sound is not we don't need people to hear a sound for a sound to exist. Feelings are how organisms experience reality. Oh, fuck you. Only relative to an organism. Whatever, fuck you. Nonsense, bullshit. Feelings are reflexes, just like thoughts are reflexes. Feelings are usually conditioned when we're kids. What we like, our taste, our sexual preference, all that stuff is conditioned. It's not rationally chosen. Where our thought process is bound by logic. We learn 2 + 2 = 4. We learn mechanics. We learn proportions. We learn weight. We learn how to measure the real world by some kind of more rational standards. So our thought process is intrinsically tending towards rational, where our feeling processes tend towards irrational. But there's no only relative to the organism crap. It's an absolute fact. Things feel. Okay? I don't need a witness. Somebody doesn't have to witness me feeling for me to be feeling. This isn't a relative thing. It's an absolute thing. People absolutely have brains. The brains absolutely do the sensation manifestation. There's absolutely no need for you to tell me I feel. I'll be doing it on my own without your fucking judgment. Thank you, chicken shit. Ugh. There are facts. I'm just arguing. It's this relative shit. It's just bullshit. If you're doing something relatively, okay, you're probably doing it wrong because it's an absolute universe. And such. Sorry, I don't mean to be so. I'm just so. I am so triggerable when it comes to anything. Just because this stuff has been shoved down mankind's throat, this whole Nietzsche crap, this relativity crap, this subjective crap, just crap. you know, if it's not happening to me, somehow it's not happening. I mean, this whole, and they even turn that into quantum mechanics, that somehow we need observers to do something. Somehow there's an observer thing. There's no observer. There's frickin' interfering or not interfering. There's no observing. I mean, it's just, Nietzsche just did what's easy. It's really easy to criticize, right? Assholes show up on this channel and they just do criticisms. They don't answer any of my questions, right? They don't respond to any of my critiques. They just criticize. And that's the easiest thing to do in the world. Tearing things down is so much easier, right? So all Nietzsche did was walk around with a sledgehammer, find a do-gooder, sledgehammer, find a decent social cause, sledgehammer, imperfect, not done right. Imperfect. So everything that was imperfect, he just hit it with a sledgehammer. I mean, what an easy job, right? Building something. Now that's hard. Making it work. That's hard. Doing the Wright brother thing, making the damn thing get off the ground. That's hard work. Nietzsche just gave up on everything. He was such an asshole. I just hate that people admire that piece of crap. And he was such a hypocrite. I mean, he was such a duplicitous hypocrite, right? Totally owned by some weird threesome he got gotten involved with some chick, and I mean, just completely owned. All right, no Mega Man at all. Completely owned by bullshit, and yet he talked this austere, power thinker when he was emotional basket case like everybody else. Howdy, Gary. I've been finishing up all of my fail festivals and now trying to catch up on your redoing videos. Bravo, very good do-overs. Currently at 19. Wow, you're pretty caught up, all right. Yeah, that's today. So yeah, well, the more, hopefully we'll get into some more interesting. The last few have been a little bit dull, but we'll get into some more basic physics stuff to contemplate. But it's been a great for me, just because I've forgotten about all these different little experiments and explaining how charge gets places. And I kind of never really thought about the charge on the glass and whether it causes charge on the opposite side and all that. And, you know, it's good to think about that stuff, or how it makes a difference. You know, if you have two plates and you slide a piece of glass in, you slide a piece of glass out, that's very different than moving the plates away from the piece of glass, right? So if you slide the glass in, slide the glass out, the glass doesn't keep its charge. But if you took the two plates and moved them away, then the glass keeps the charge. You know, just interesting little, you know, ways of recognizing how it really matters. These little details matter. I mean, it's, you know, I just last comment on the Nietzsche thing. So I'm just getting to the point that what the world needs is people invested in civilization and willing to do the best they can to engineer Rube Goldberg social mechanisms that work as good as that we can make them work. That's what the world needs. People trying to be the Wright brothers. People trying to get the civilization off the ground. And he was just a give-upper. Fuck it. And that's just such bullshit. Tear everything down. Somehow, if we all are selfish cunts, everything will work out. No, it will not. Everything will be Jurassic Park. You know, so Tyrannosauruses didn't have civilization. Crocodiles don't have civilization. You know, and your mega Nazi man ain't going to have a civilization. Be all that nature made you is not going to make civilization. Wow, it went up to like, I thought it went up to like 16 viewers, and it's down to 8 again. That's pretty funny. Must have been trolls trying to get in or something. So it looks like we've wound down. So we'll call it an afternoon. Yeah, I just figured it would probably be a good time Sunday, right? Not a weekday. People in Britain are still awake, almost. You know, California, they're awake now. So figured it would be good, but no, not so good. So anyway, just try again, such, so forth and whatnot. Keep doing my thing. So probably one of the next videos I have to do I'll do parts to the new video on the one. There's only one field theory, the one field theory, and you know, and so that's going to be like an incremental, another series of videos. Yeah. Part 2, Part 3, Part 5, all that stuff. All right, whatever. Hey, Gary, do you think it makes sense for an AFLIS to work on sustainability engineering? It doesn't really matter. The flux, the earthquake is doing this. What the right thing to do when the earthquake's doing this? Who knows? I have no idea. You have to feed yourself, so you have to do work. You have to get a job. You have to do all these things. I'm just saying, what do I know? Where the best place to hide is, and where you'll survive to fight another day, because that's all you got is hope, is being able to manage as much as you can while it's manageable. But that's all there is. So I don't have any. If I had a plan, I'd be implementing it. I obviously don't have one. Apologies for unrelated to fix. I never catch your Mindem streams. It's okay. It's a simple enough question, so we'll give it to you. And such. I mean, it's not that simple a question, but I just mean, yeah, I don't have advice. I don't. Because the right plan, it's just too hard to figure out what that right plan is. The stupid things, You could just walk down the street dropping banana peels, and you could just hope that all the right people slip on them. It's just so, there's just no way to know where the right button to press is. They're all just the same color. It's just a bunch of buttons. Like, I don't know. I'll press this one. Does that work? I mean, it's just too unknown. I mean, you obviously don't get some bitch pregnant. Don't press that button. That's probably not anywhere near the right button. All right, so I think we're finished now. Oakley doke. So till the next time, and such, and so forth and whatnot. Yeah. Love you. Probably not really.